So coming back to the session, there is a power failure, so that's why we are not able to record further. So we have stopped this, but now it's restored. So let's again go back to the problem. We are discussing this problem and the sensitivity of this problem. So we have already discussed that what is the range of optimality and what is the range of feasibility. So here we are discussing the shadow price and what is the use of shadow price. So shadow price is nothing but it will give us an idea that what unit change. If I changing the unit RHS of this second constraint by 1 unit, then I will get a change of 0.6 in my objective function value. Okay, so it will give us the amount of change in an objective function by changing the right hand side of the constraint. So here we are discussing that if we are changing the RHS up to this value, then what will be the change in our, so in this range, if we are changing, then we will see that right hand side is changed. So our RHS is Z value change, our product mix is changed. Okay. So here you can see that binding constraints, these two, and here we have our original value of objective function is 17.6. Then now I am getting 18, and then what is the change we have done in the right hand side of the second constraint, that is 0. Yes, here all are binding constraint because 10 is also 10 equal. So by increasing this, we are making the second constraint a little above that, whatever it is originally. So it is coinciding with the 1 point, all three constraints here graphically if you see. But right now I'm focusing on the shadow price. So shadow price is so if fixed. So what the change I'm getting in the objective function is 0.6 into the change in RHS, that is 2.3. So this is giving us a change equal to 0.4, right? This is nothing but equal to 0.4. So when it is 0.4 and that is added to our original objective function and it is making it 18. So here you can see that by looking at the shadow price, I'm able to find out that if I change this with the whatever amount, I multiply that into this will give me the change in my objective function value. So how much? So here in this value, I have increased my RHS and my objective function is now increased. That means it's a minimization problem. My old one is better than this one, I can see. That means the cost I was having earlier, so giving so making this constraint more allow more value here is not a good idea at all. So let's see second example. So if I take this 13, so by taking 13, what I want to show that if I am going out of the range of feasibility for this, according to my feasibility range, it should be only 12.67, not more than that. So let's see what happened. If I am taking it 30, I have changed a unit. So here now present earlier value is this, present value I got 18.36. I have changed a 1 unit in RHS. So 0.6 is the, so 0.6 is the change here. And you can see these first two constraints are binding now. So my solution point is changed now. These two values are changed. My point of X value and Y value is changed. And the third constraint is non-binding. Right? I think everyone is getting this. Now the third example, again, let's see. Third example. In this third example, I'm reducing this to 12 to 11. 11 is again, you can see, is within this feasibility range. So if it is in the feasibility range, then I think I will improve the solution, or maybe it will remain so. So here, RHS I'm taking it, okay. So okay, fine. Third, 11. So if it is 11, then again you can see my binding constraints are for this two. And first one is not the binding constraint. Original value is this. And now I am getting 16. And you can see the change in the X and Y value also. So how much I changed in the RHS? I had decreased the RHS by 1 unit. So when I decrease this by 1 unit, so I have changed it -1. Shadow price is 0.6. So 6 into 0.6 into 1 is 0.6. So I subtract this from 16.6, the old value. So 0.6 difference is there. No, I have decreased. The change is -6. So we have to subtract this change in from this. Or you can say you can multiply it with -1. Okay. So you have to, if you are adding this value to this, then you have to write it here, -1. Or you can understand that if you are decreasing it, then you have to subtract the value. Or better is you can change, you can represent with the negative if it is less than whatever is the earlier one, and then you consider it here also. Okay. So now let's go and play with the first non-binding constraint also. So in the example, as I said, the first constraint is non-binding constraint. So let's do this exercise also. So here, if I'm changing the non-binding constraint coefficient here, 10.20, 10 point up to 10.4. So here you can see the sensitivity report is saying minus to infinity to 10.40. I can make a change in the right hand side of this constraint, will not affect my solution. So you will see here. So 10.4, 10.4. This is binding, and this is binding. All three are binding constraints. Actually, and change I have done +4. But for this, you can see we have shadow price 0. So for the initial problem, if this is a non-binding constraint, then it's not playing a role in objective function value, right? So it is not a binding constraint, so it's not playing any role. We don't have anything to do with this within this range, within this range. So what happened here also, if I added 0.4, but shadow price is 0, so there is no change. So sensitivity report also telling us that how much change is allowed in the right hand side of the first constraint or non-binding constraint will not affect our solution. This remains the solution of the original as it is as a original problem. Again, the power is gone. Oh, it's coming. Okay. So here it becomes second, third, and fourth. First, all are three binding constraints, and our solution is remain same. So within this range, so by using this sensitivity analysis, if I change my right hand side 10 to 10.4, I know that there is no change in my product mix. Whatever production plan I am following, I need to follow that only. No change. So there is no need to run the Excel again to solve the problem, because within these range there is no change. If non-binding constraint, if I'm saying I'm changing in non-binding constraint. So let's say the fifth case. The fifth case again I'm doing it within this range. Then you can see again this is non-binding, remain non-binding, but the same thing, we don't have to check the solution once again. So I think this is everyone has understood what happened when we are changing the right hand side of the binding constraint or non-binding constraint, and what actually it is giving us, what is the interpretation of this. So up to here it's clear. So should I take I will take a break for 5 minutes and I will come back and discuss the next thing, how to play with the coefficients of x and y in an objective function and what its interpretation. So we will talk about, yes, we have already a big break, but it's just 2 or 3 minutes. So, okay, we'll continue. So, okay, so this is the old example, and again the same thing. The solution is objective function value is 17.6 and x value is 3.2 and y value is 0.8. Okay. Now, if I see the sensitivity report, I have reduced cost here. So reduced cost and objective function value is 5 and 2, coefficients value, and we have calculated already the range of optimality. So that means if I change this 5 within 2 and infinity, in this range, if I change it, I have no problem with this solution. Similarly, if my 2 will take value in between, if I change it with any value in between minus 1.25 to 5, our solution will remain same. So let's see. Okay. So here first example is with, okay, I will change it. So here I have make it 5 here, you can see 5 in place of 2 I replaced it with 5. Okay, so optimality range is for this maximum 5, so 2 to 5. And now again running the solver, minimization, let's go to the solver and solve. sensitivity report is already there, so I'm right now not taking it. So here you can see that our two constraints remain the binding constraint. Our solution x value, y value remains same, but z value is changed here. Z value is changed because the coefficient is changed here, right? So here you can see what we are getting from this exercise, that our coefficient of objective function original is 2. Now we have make it 5. Solution remains same. And objective function, as I increase the value of 2, so it will increase. So within this range, it's still these two are same. Now let's take another example. I am taking its lowest bound for 2 minus 0.25, and now you can see this remains same, and I got the objective factor value decreased. So you can see how much you want to change this coefficient. So you have a levy to change it. So cost function is this. So you can so you don't want to change your production, right? But the same time you can talk to vendor that uh, if it is increasing the uh, suppose it is increasing the cost of the buy material, or then how much you are getting total cost change, so that you can adjust and negotiate then in that on that basis. Similarly, if it is decreased, then also you have to know that how much your coefficient value will decrease, and then accordingly you can see that do you want to this or not. So happily you can want this. So now let's see this one. What happened when we go beyond the feasibility range? So our feasibility range is minus 1.25 to 5. Now I'm taking that y value from in place of 2, it is 6. So if it is 6, then what happened? Let's say again I run this. After doing the solution, run the solver, you can see that these two values, x value and y value, is changed. Now, if it is going beyond the feasibility range here, optimality range, then you have to change your production schedule. X value and Y value is giving how much product you have to produce, X product and Y product. Now this is changed, and your objective function value is also changed. So solution is differ now. So beyond this, it is differ. So I think now you understood what is feasibility range, what is shadow price, and what is reduced cost. Okay, reduced cost is the cost. It should be non-zero in if my x and y are playing a role in giving me objective function values, then these two reduced costs should be 0 always. This is giving us the objective function coefficient improvement. So no improvement here. It's showing. So let's play one more. Okay. So I just take a copy. So okay, this. Suppose if I replace this with 20 and see what happens. Okay. So data, solver, everything is on place. Now I'm going to options, linear model, and non-negative. Okay. solve. Yes, I want to get another sensitivity analysis also, so go for that. So here you can see the y value is 0. When y value is coming out to be 0, that means y is not, we are not going to produce y product. That means it's not participating in our objective function value, right? So when it is not participating in our objective function value, when we have this reduced cost. So we have this reduced cost, and we have, so when the variables are having non-zero final value, then reduced cost must be 0. When the final value of the variable is 0, then we have some reduced cost. So reduced cost will give us that allowable decrease and allowable increase. So this is infinite. And allowable decrease is 7.5. So you can reduce this 20 to 20 minus 7.5. If you take, then it will become 0. So I think I have covered sensitivity analysis. We'll do one more problem after taking a break for a few more minutes. So I'll take a 5-minute break now. Right now it's 3:16. I'll be back by 3:20, 2021. And we will, so we have done this part of the use of solver for sensitivity. Now we'll do this problem of bike company.